When we calculated capacitance from its definition, we said it was Q over the potential difference between two plates. But we also were able to calculate capacitance in another way, in that we knew that there was an energy density for an electric field which was equal to 1/2 epsilon naught E squared, and our total energy was equal to the integral of this energy density over a volume. And we saw that in charging up a capacitor, the energy, this is the energy stored in the electric field in the capacitor. Well, for a capacitor, we could have written that as Q squared over 2C, and that was also equal to 1/2 C delta V squared. So there's really a couple of ways to calculate. The capacitance, we could calculate capacitance as I showed up here, method 1, or we could calculate the capacitance if we knew what the stored energy was. And you can see there, you could write that as Q squared over 2U. That's one way to do it. Or you could write the capacitance as equal to 2 times U over delta V squared. So these are alternative ways to calculate capacitance if you can calculate the stored energy, U. Now, we have a similar idea in terms of self-inductance. So we can call all of these equations two alternative ways to calculate capacitance. With inductance, self-inductance, we defined it as magnetic flux divided by current. And we saw for the solenoid, we could calculate the self-inductance that way. But we also saw, even though we used the solenoid, that the energy density stored in magnetic fields is given by 1 over 2 mu naught B squared. And the total magnetic field energy stored, let's call that electric, we'll call this magnetic, is the integral of that energy density over the volume where it's stored. And we saw that that was equal to 1/2 L I squared. And so we have our second way of calculating self-inductance. If we knew the stored energy, then the self-inductance is given by 2 times the stored energy over the current squared. And so these are two separate ways to calculate self-inductance, mirroring the same idea for capacitance. And now let's look at an example where we'll look at another way to calculate the energy stored in a solenoid and get the self-inductance that way.